Writing equations of sine and cosine functions. For this, we'll use our knowledge of midline, frequency, period, amplitude, and the basic sine and cosine parent functions to write the equation of a given graph. Here, if we take a look at our first problem, we can start to look at the midline. Now, for the midline, there's two ways we can find this. First, you can take your max plus your min y values and divide those by 2. So here we can see we're at a positive 2 and a negative 2. 2 plus a negative 2 divided by 2 is equal to 0. So our midline is going to be at y equals 0. Another way to see is where is the line that's going to divide this graph in half? And here we can see that it's oscillating over the line y is equal to 0. So my midline is going to be y equals 0. For my frequency and period, I'm looking for that change in b value. I'm looking at the graph and saying, where are my 5 key points located? Remember, those 5 key points that we keep talking about are coming directly from our parent functions. So I'm looking for here's 1, 2, 3, 4, 5 key points. So for those 5 key points, I can see that's happening from 0 to 2 pi. So therefore, I was able to complete one full curve from 0 to 2 pi. So that's my frequency would be equal to 1. My period, since my frequency was equal to 1, that means my b value must equal 1. So my period is just going to be 2 pi because period is 2 pi over b. For my amplitude, I'm looking at the height of the graph. And from here, I can see the height of the graph has changed from its parent function. Usually for a basic curve, it just kind of goes up to 1 and then comes down. In this one, we're going all the way up to 2. So that's going to give me a height of 2 or an amplitude of 2 for my graph. Now, to determine whether this is a positive or negative a value attached to that, then I need to take a look and see where the graph starts off. So it starts at 0, 0, and then it goes up. If this was a negative graph, it would have gone down. So therefore, for this one, we know that this will be a positive graph. And now determining whether it's going to be sine or cosine, I generally look to see exactly where that y-intercept is. Right here, we're at 0, 0, which is where a sine curve basically starts. It starts at its midline and goes up to its max. Whereas a cosine curve will start at its max and go down to its midline. So for here, we're going to call this our sine curve. So with all this information, knowing my a, b, and c values, I can write the equation of my given graph as y equals 2 sine of x. In our second example, we're going to use the same idea of finding our a, b, and c values in order to write the equation of our graph. First, we're going to take a look at our midline. The midline, remember, is going to cut our graph right in half. So here, I can see that the midline has made a little bit of a shift here. So that's going to be my midline. I have the same distance above and below. You can also go through, if you can't visually see that, you can take the max plus the min and divide by 2. So my max in this case is going to be 3 plus 1 divided by 2 is equal to 2. So here my midline is equal to 2. That also means that my c value of my graph is going to be equal to 2. For my frequency and period, I'm looking to see where my 5 key points are. I have 1, 2, 3, 4, 5 key points. All 5 key points are occurring between 0 and 2 pi. Therefore, I know my frequency is one curve in 2 pi, and giving me a b value equal to 1. My period is going to be 2 pi divided by my b value of 1. So I have a period of 2 pi. For my amplitude, I'm looking for the height of my graph. And we can see here and also here that the height of the graph is going to be equal to 1. To determine if this is a positive or negative graph, we can start to look and see where our graph is starting. With this one, we're starting above our midline and kind of working down and then back up. That follows the basic curve, this starting in our positives and going down to our negatives of our regular parent function. This graph was definitely not reflected over the midline there, so this is going to be a positive function graph that we have. Next, we want to determine if we are going to be using a sine or cosine function to represent this. And because we're starting here above our midline at our max, going down to our min, and then ending back at our max, we are going to represent this with a cosine function. From here, using my a, b, and c values, I get that the graph shown here is y equals cosine x plus 2. In our next example, we want to start off by finding our midline. If I take a look at my max value of 1 and my min value of -1, I can see that my midline will go right in between at y is equal to 0. Because my midline is equal to 0, I know that my c value of my function will also equal 0. Next, I can take a look at my frequency and period to help me determine my b value of my graph. For this, I'm looking for my 5 key points. So as I start to find these, I get 1, 2, 3, 4, 5. So there's one complete curve, but I'm not sure exactly how long it's taking me to complete that one curve. So let's keep going. So now we have 1, 2, 3, 4, 5. That's a second complete curve. And 1, 2, 3, 4, 5. That's a third complete curve. So though I'm not exactly sure how long it took me to do one curve, because it's kind of in the middle there, I'm able to definitely determine that from 0 to 2 pi, I was able to complete 3 total curves. Therefore, that makes 3 curves in 2 pi, giving me a b value that's equal to 3. I can then use that b value to help me determine my period, which is going to be 2 pi over b, or 2 pi over 3. My amplitude is going to be the height of my graph. And for this graph, we can see all along here, the height is just going up to 1. So therefore, my amplitude is equal to 1. This graph starts off at 0, 0, goes positive, and then back down to negative, and then ends back at 0. So this follows a basic sine curve, and it is not reflected because of the motion that it's going from 0 to positive, 0 to negative, and back to 0. So for this graph, we can determine that it is a positive a value, and it is a sine graph. So if I went to write the function of this graph now, it would be that y is equal to sine of 3x. In our final example, we'll start off with our midline as usual and take the differences, add our max and our min. So here we're adding a 0 plus a -2 divided by 2. So that gives me a -1 as my midline. Or you can just kind of visualize to see what is splitting that graph in half. So that means my midline is going to be equal to a -1, which means that the c value of my graph is also equal to a -1. For my frequency and period, I'm looking for my 5 main trig points here. So I have 1, 2, 3, 4, 5. So I was just able to get a complete curve here, 5 whole trig points just from 0 to pi. So that means I can complete one curve in pi, or I can complete 1, 2, 3, 4, 5, or 2 complete curves from 0 to 2 pi. So therefore, my frequency is going to be 2 curves in 2 pi, which means that my B value now has to equal a 2. We can then confirm the period by using our formula of 2 pi over B, which is 2 pi over 2, which would mean the period would have to be equal to pi. And indeed, we did see that we were able to complete one curve from 0 to pi, so that checks out for us. Next, we want to take a look at our amplitude, which is the height of the graph. Here, our height is just going to be equal to 1. And now we need to determine if we are going to be a positive or negative graph and what type of graph, sine or cosine, we are. So because we are starting above the point 0, 0, we're starting at our max, we're going down to 0 and then down to our minimum. This is going to be indicative of what a cosine curve would start off as. It also follows the positive motion of a cosine curve. So for this one, I would say that I have a positive cosine function. I can write my final equation using my found a, b, and c values as y equals the cosine of 2x minus 1.